Welcome back to our discussion of array lists. We have plenty of new material to talk about tonight, but first let's review what we know so far. We've learned quite a bit already about the behaviors that array lists have, and I'd like to just go over them, and the way I would like to do that is to go through a quick example. So let's say I have an array list called myList. How do I add an element E at index 3 in my list? Take a second to think about it. Hopefully your answer was mylist.add 3E. And if you don't remember how this works, add, in this case, takes two arguments. The first argument is the index where we would like to place the element, and the second argument is the element itself. Moving forward, how do I get the element at index 0? Hopefully you said mylist.get0. Mylist.get just retrieves the element at a given position. How do I add an element E to the end of the array list? Well, that's just mylist.add E. Remember, add with only one argument automatically places the element at the end of the list. What if I want to remove the element at index 2? Hopefully you said mylist.remove 2. Remember, the way this works is we identify the element at index 2 and we simply remove it from the array list. And what if finally I want to find the length of the list? What if I want to determine how many items are in the list? Well, if you remember, that's just mylist.size. So this is a quick summary of what we've learned already. Now let's move on to the new material. Today we have three things to talk about. First, I'd like to talk about how we search for things in array lists. Then I'd like to talk about another method of iteration for array lists. And finally, where we're going to spend most of our time is on something called wrapper classes. So let's get started with searching. ArrayList provides us with three methods to help us accomplish our searching goals. The first is contains. And contains takes one argument and returns a Boolean that says whether or not that element is in the ArrayList anywhere. So it returns true if that element appears anywhere in the array list and false if it does not. Index of is just like index of for strings. It takes one argument, the element we're looking for, and it returns the index of the first occurrence of that element. And it returns -1 if that element is nowhere in the list. Finally, similarly to index of, last index of returns the index of the last occurrence of an item in a list. So keep in mind that a particular item might occur several times in a list. Index of will give us the first index, and last index of will give us the last index. And once again, it will return -1 if the element is not in the list. So these are pretty self-explanatory methods, but let's go through a couple of examples. I've set up a list here called list. It is an array list of strings, and I've added 3 elements. I also have 2 Booleans here, and I want you to take a minute and figure out what the values of those Booleans are after this block has finished executing. Hopefully you got true and false. The first one is true because hello is in the list, and .contains returns true if the item is in the list. And the second one is false because goodbye is not in the list. Now, same list, but instead of booleans this time I have integers, and I'm calling index of. So what are the values of hello and bye going to be? Hopefully you said 0 and -1. The first one is 0 because we return the index of the first occurrence of the element we're looking for. The element we're looking for is hello, and that's in index 0 and in index 2. But the first occurrence is at index 0, so that's what index of returns. And goodbye returns -1 because goodbye is not in the list. Finally, for last index of, on the same list, what are our values of hello and bye going to be? Hopefully you said 2 and -1. So, just like on the last slide, hello is in this list twice. It's at index 0 and at index 2. Last index of will return the last index where that element is found, and in this case, hello is found at 2. That's the last place that it's found. And once again, goodbye is -1 because it doesn't appear anywhere in the list. So that's it for searching. We have contains, index of, and last index of. Now, on to our second topic, which is our second kind of iteration. Now, you've seen this kind of iteration before. It's called a for each loop. And we did this kind of loop while iterating through arrays. And in fact, for array lists, the syntax is exactly the same. Based on this block of code, you actually don't know if list is an array of strings or an array list of strings. Now I'm telling you it's an array list, but the point is that this syntax should be familiar. First, we say what the type of our loop variable is, and then we say this is the name of our variable that each element is going to be assigned to. And then finally, we specify the actual thing that we're iterating through. In this case, it's an array list. And remember that the way to read this is you read the for as for each and the colon as in. So this is for each string s in list. So exactly like it was for arrays, just a different way of iterating through. Rather than using an index and getting elements, we take care of it as part of the loop. Now, so far, we've only had array lists full of strings. What if we want to make array lists of other things? Well, that's easy. We can make an array list of cars, or an array list of shapes, or an array list of dates. We can even make an array list of objects. That's the most generic thing we can possibly do. Basically anything could go in that array list. Or we could make an array list of ints. Or could we? Actually, it turns out that you can't make an array list with a primitive type. Because of the way generic classes work, you can only use reference types. And remember that primitives are value types. So we can't make an array list with ints. But it seems like this is something that we should be able to do. We want to make lists of primitive-like things. We want to make lists of numbers and lists of booleans. So how do we do that? Java provides us with what are called wrapper classes. And they're very well named. They're exactly what they sound like. They're objects that wrap around a primitive value and allow us to pass that primitive around as if it were a full-fledged object, because technically it is. So every primitive in Java has a corresponding wrapper type. For int, the wrapper type is integer. For double, it's double. For Boolean, it's Boolean. And for char, the wrapper type is character. Now, the way that we make a new object of a particular wrapper type is the constructor takes one argument, and that is the corresponding primitive value. So we see right here, I'm creating a new integer object with the int primitive I. Now this may all sound very pedantic and silly, but it's important because this is what allows us to make array lists of ints or doubles or chars. So once again, what the wrapper class does is it encapsulates the primitive value inside of an object so that the primitive value can act like a full-fledged object. So now you can see right here, I'm creating an integer object with the primitive value 6. Then I'm making an array list of integers. Not an array list of ints, an array list of integers. And then I can add my integer object to the list. Well, fortunately, we can, thanks to boxing. Boxing is a feature built into Java that automatically converts a primitive type to its wrapper object in particular situations. So what that means is that we don't have to explicitly create a new integer object when we want to add an int to our array list of integers. We can just do it directly, and Java will automatically convert the int to an integer and then put it in the list. So these 3 lines of code down here are completely legal, and they result in an array list with 2 integers in it, 6 and 17. Now, fortunately for us, the reverse is also true, and that is called, not surprisingly, unboxing, which is automatically converting from a wrapped object to a primitive value. So we can see down here what I've done is I've declared an int, a primitive int variable sum. And I've set it to be the sum of the first element and the second element in our list, which were 6 and 17 respectively. And then I print sum. And what do I get? Well, I get 23, as we would expect. And how this is working is when I call intlist.getZero, it's taking the integer object out of position 0 in the array list, and it's converting it back into a primitive int for me. And it's doing the same for the integer in index 1. So then I have 2 int values, 6 and 17, and I add them together, and I get 23. So, boxing and unboxing, pretty cool. They allow us to automatically convert between primitives and wrapper classes. But more productively, what that really means for us is that if we want to make an array list of ints, we can. The only time we have to reference the wrapper class is when we're making the array list. We have to say it's an array list of integers. We can't say it's an array list of ints. But then we can treat it as if it were an array list of ints from then on. So, we learned 3 things today. We talked about searching with contains, index of, and last index of. We talked about for each for array lists and how it was exactly the same as for each for arrays. And then we talked about wrapper classes, and boxing and unboxing, and how we can make array lists of what we can then treat as primitive types. So, your assignment for tomorrow is to read in your textbook pages 653 at the bottom to 666, which is the end of 10.1. And that is a review of what we talked about just now. But also I'd like you to pay particular attention to 658 to 662, which goes over some of the common pitfalls that you run into when working with array lists. And we're going to be doing some activities with that in class tomorrow, so please be prepared. Until then, have a good night, and I'll see you in the morning.